stuff under the hood, how we do actually things, is for the hackers among you.
So, hi, welcome to today's .NET Meetup. Thanks, Gael, for coming here.
Thank you for having me.
Before the stages is some general stuff as usual. So, thank you all for coming. Without you, it would be a little bit boring. Then, also thanks to our sponsors. This is, as the last time's Tech Talk, which is sponsoring the location and pizza and beer. Pizza is ordered for 7, so someone around 7 is there, and we will have a short break, and then we will continue with the talk. Yeah, some short commercial breaks. Next week we have, the Tech Talk has a training about surviving legacy code by JB Reinsberger. JB, the cool trainer. You have still a chance to book the training. On the 16th of November, Tech Talk has the Global Code of Code retreat here. It's a cool event on Saturday about a whole day of coding and solving one pattern with different obstacles. And the last stuff is you can rent this room also for your company or your meeting. That's the DC Space is offering. Tech Talk is provided. And that was the commercial break. General stuff. If you want to host a .NET Meetup, like Tech Talk is here, we are looking for new locations or additional location sponsors for the next year, that we have a little bit alternatives and other view and see other offices than this one. If you want to host something, come to me or to Martin, who is still at the front desk and letting people in, and let's have a quick chat about it. The next meetup on the 4th of November, we have 2 talks. Modern Authentication with OpenID Connect by Martin, and Everything You Don't Want to Know About Async Await by Stefan. Yeah. December slot is still to be defined, and that's where our request topic lists come in. So we have a small backlog of topics we would like to have talks about. Notre Dame packets, new Blazor. Somebody played around a little bit with Blazor, no more than me. Nothing. Happy to talk about how we can give you a stage to present something. Yeah, one important word. Please spread the word that we are existing. So invite colleagues, invite friends, invite customers. That's a cool opportunity to learn new things. Tweet. We have a dedicated Twitter account now. .NET-AT. Yeah, and invite everybody who has anything to do with .NET. We are streaming, like now, hopefully. I didn't check it. At Twitch. And the recordings are on YouTube. Please subscribe, because until we don't have 100 subscribers, we have this ugly URL. If we have more than 100 subscribers, we can change this URL. We are currently at 42, so subscribe. With private accounts, with corporate accounts, subscribe. Yeah, that was it from my side.
Thank you.
So, Gael,
thank you very much.
It's your stage.
Wait, there's so many PowerPoint open. I cannot close your, right?
Yeah, you can close it.
I can close it. Okay. So I'm changing a bit the the prepared slides. This is why you see that this is a UK speaking tour and not the dark one. So today we are in Vienna, tomorrow Munich. That's about it. And then last week it was, and last 2 weeks it was in Czech Republic with 4 talks. So in this first part, by popular request, I will talk more about PostSharp and how to think about that, the value it can bring to you. That was not really what I planned. I'm happy to talk about that because, you know, this is what we're doing. So let's start with that now. I'm Belgian, actually. I moved to Czech Republic in 2001, but that's something maybe you know from Belgium, is the pipe. This is Magritte, yes, this is Magritte. I like to show this pipe because I think to program better, it is good to think about programming as an activity, like thinking about reasoning about programming itself, not just programming, but thinking about programming. And so this is kind of adding a level of reflection on what we are doing, which Magritte, Magritte here wants us to do, is to think about, you know, this is not a pipe, it is an image, or it is a set of pixels, or it is an impression on Retina, but this is not a pipe. So let's talk about programming. This is not about programming. So PostSharp, how of you know about PostSharp? I started working on PostSharp in 2004. It was an open source project, but by then I remember in these days meeting in Vienna with members of the Spring.NET project was partly based, the Spring project was partly based in Austria, in Linz also, so we had a few meetings. That was fun until it became too big for me, actually. Then I started to build a company about that, around that, and now we are 9. We are all based in Prague, and we have customers all about the world. So the agenda of this first part, I will talk about the philosophy, because I believe it's important to think about programming. Then I will introduce the problem that we are solving, which is the pattern keyword. A few words about aspect-oriented programming, which I now consider as being a bit obsolete from a communication point of view, but it's still a relevant base, and how to do it with PostSharp. I'm not sure if I will go to the case study. I could go directly to the next part. So let's start going back in the past, thinking about design patterns. I guess you all know design patterns. It is now a part of the body of knowledge of software engineering, and we know it as a software engineering community. We know it from this book, from the Gang of 4, that was written in '95, and I believe that we consider that book as a kind of Bible. Bible in that meaning that it's not something that you are, it's something sacred that you are not allowed to interpret. Not going to deep in religious topics or different interpretations of the Bible here. My point is to say that we give much importance to this book, and I think it brings us to a situation where we believe that all design patterns must be in the book, otherwise they are not patterns. And I think this is a myth, and to get I think it pays off to get back to the sources, to the book and the author who inspired the Gang of 4 to write software design patterns. And this was written like in 1977. An architect introduced the notion of patterns for software architecture, and he was struggling during decade of his career, I think during at least 3 decades, he was struggling with a question: how is it possible that any simple farmer could make a house, a barn, 1,000 times more beautiful than all the struggling architects of the last 50 years could do? He was talking from the 70s, disasters were done in Western Europe with architecture, and it got better in the meantime, fortunately. But this is an example of beautiful folk architecture, and you see there are patterns, like the houses, the shape of the roofs are identical, the facades, there are 2 patterns of facade, there are 3 windows on the ground floor, and 2 on the first floor, and 1 on the second one. There are some patterns, color patterns, and so on. So Christopher Alexander created this concept of patterns, and he said we live in a world of patterns. To have patterns, you should have regularity, and you should have 2 things: variety. Regularity, like for instance, any time that you have gravity, grains of matter, and a stream of some fluid like water or wind, well, you get waves. Waves is the pattern. Variety means, like, here we have a pattern in microbiology, but we have different instances. A pattern is a system of resolution of forces. Here they are like physical forces, but they are also economical forces, psychological forces. Why do we build in Central Europe? Why did we build spiritual places this way? Patterns are everywhere, not only in physical systems, in biological systems, in architecture, but also in social organization. So the representative democracy may be a pattern of social organization. Software patterns are self-sustainable. I will skip that. And patterns form a language, which is the important point. Because patterns, they create the words. Because our brain because we create these patterns, we actually are able to talk about our trade. So here is a couple of patterns for carpentry that was found in the book Carpentry for Boys in 1914. But as a part of learning the trade of being a carpenter, you had to learn all these patterns, how they relate to each other, when to use them. And patterns, according to Christopher Alexander, and also for me it's an important thing, is they are essential to the way we human beings communicate, we reason, and we improve our trade. Patterns are not just things in the book that you are not allowed to touch, because otherwise it will no longer be the pattern. This is, I think we are now looking at patterns at a way that may be unproductive and far from the initial reality. And the reality is that patterns belong to people. We can bring them back. If you have something that repeats, it is a pattern, and we can use a pattern way of thinking. So a second myth, programming is a mathematical activity. And I believe that the real challenge of the 21st century is not to cope with like scarcity of CPU resources, scarcity of memory or storage. It is really to cope with the scarcity of human intelligence, the amount of smart people you can actually put on your project. This is what is hard, and it is probably what companies are struggling for. For a given budget, in a given location, you can only find a limited amount of intelligence. You can probably find an unlimited amount of stupidity, but intelligence is different. So, so when we write APIs, when we design APIs, we build things for developers. Why do I have that here? I'm going to skip that. Yeah. So my view of patterns, and what I've measured too in all these years working on PostSharp is that anything that is repetitive deserves to be treated as a pattern, even if it is not in a book. And when we have a pattern, we allow for communication. But that is quite important. When you have a pattern like immutable, you do not need to repeat this class cannot be modified after the constructor has completed. You just need this class is immutable. So we can think about it. It raises the level of abstraction of reasoning. And it is important to focus on reasoning because programming is not mathematical and it is basically a human activity. So, when we design software, especially when you design software as an architect for a big team, you are basically designing software for the rest of your team. You are designing an architecture, a framework, so that the rest of your team for the next 5-10 years can actually build software. You are not primarily building software for the CPU. If you do that, you are probably going to need to do a big refactoring sooner than later. So patterns are so important for all trades, including software engineering, but in the C# language, we do not have the pattern keyword. There are some things like make the class immutable, implement notify property change. These are patterns. We know how to implement notify property change. The thing is that we need to execute this thing manually because the compiler does not support this level of abstraction. The compiler supports class methods. It does not support pattern keywords, so we end up with boilerplate code. It just has, it is as if you had to build an industrial building with bricks and mortar. You need to do a lot of things. So we get a boilerplate code with things like notify property change on the redo, logging, threading, these kind of things. And you end up with this ugly thing that this should be your, like the green code would be the useful part of the code, and you end up with a lot of boilerplate around that for transaction handling, logging, exception handling, and so on. Okay. So far, I've tried to reframe a bit design patterns, that it is more important than we believe now. And say that it totally makes sense to introduce that to the compiler. That was my 2 points. And because we are not doing that, we have to write this code manually. There is high development effort. We are doing bugs. It is difficult to maintain and so on. So these are the problems. And what PostSharp is doing is filling that gap. So this is conceptually what PostSharp is doing. I will skip that. And now I will show you an example of how PostSharp works. Going here to this application. This code is not relevant. So, that's a very simple application. But it shows you how the world could be with a compiler that supports patterns. So here is a contact, and the contact may have several addresses. And here I have a field, a composite property that is made from different kinds, different subproperties. And this gets updated because I implement notify property change. So how do we implement notify property change? Normally, well, we would run mentally an algorithm. We would look at property getters. We would map property getters to fields if we use fields. And then we would look at all methods modifying the fields, and we would call onProperty change for each method modifying a field and for each property. This is the way, like the manual way of implementing design patterns. Now, with PostSharp, and I hope in the future with pattern-oriented compilers, what you do is that you add a custom attribute that tells the compiler what you want. You actually want notify property change to be implemented here. How to implement notify property change? Well, we actually did that for you. So we added here to the model base, and then the source code can remain clean without boilerplate code here. Here I have a composite property, and PostSharp understands all these things. And here is another case where we have a property that this composite property that depends on the property of a property of a property. And you probably know how to implement that. It is not complex, it's just laborious. But again, it's enough to add a custom attribute. Because this is a pattern, because it can be algorithmically implemented, you can teach the compiler to implement this thing. You do not need to execute the algorithm yourself. So this is what PostSharp is about. We started, or I started, with aspect-oriented programming. That was invented 25 years ago. It was implemented in Aspect-J. If you come from Java, you would know about that. I believe now aspect-oriented programming, I see that as a technology. I do not see that as a philosophy that is similar to object-oriented programming. It kind of allows you to do some hack. I find it much better to think in terms of patterns rather than to think in terms of aspects. Aspect-oriented programming, basically what it does is that it says that in your solution domain, in your source code, you want the code to be separated in different kinds of components, namespaces, files, assemblies. But actually, in the real world, you have cross-cutting concerns. These features are cross-cutting. So aspect-oriented programming is a technology that allows you to express complex reality with separation of concerns. And for this, you have first you create an aspect, and an aspect is a collection of transformation. And then you apply the aspect to the code. And because the aspects do not know about the target code, and the target code does not know about how the aspect is implemented, you can actually separate the aspect, for instance, modify property change or logging. You can separate that from the business code. Okay, and here we are. So that was kind of an introduction. I wasn't fully prepared at this time. So now more about PostSharp. You got a lot about the philosophy of PostSharp. So, but about PostSharp itself. At the base of everything, there is an SDK that you do not need to study. This is what PostSharp programmers, PostSharp employees have to study. It takes a lot of time. I would say 6 to 12 months is to become productive with this SDK. So this is not your problem. Based on that, we have the aspect framework. The aspect framework allows you to build your own aspects. And based on the aspect framework, we created ready-made aspects. So for instance, logging, for instance, notify property change or dependency properties or code contracts, for example, or threading model and caching parent-child relationship, and disposable. These are, like PostSharp is all these. You have the framework that is actually sold as a separate product, and then you have all the aspects that we built on the top of that, so that you do not need to build your own. Okay? Questions so far? Yes?
How does the deadlock detection work?
Deadlock detection, this is an aspect that we apply. It intercepts the calls to, for instance, monitor.enter. So it modifies your assembly. So PostSharp works by modifying your assembly after C# compiler works. And when you call, for instance, monitor.enter, which is used when you have the lock keyword, it compiles to that. We intercept that, and we create a graph of dependencies between threads and objects. And we analyze cycles in this graph. When there is a cycle, we throw an exception. So this is a runtime thing. And this was pretty well with threads. The current production version doesn't work pretty well with async, because there is a whole new set of deadlocks introduced by async, where you like async tasks and wait for each other. Other questions? So actually, deadlock detection is an example of an aspect that is not a pattern. It's a tool. It doesn't really fit in my pattern philosophy. Okay, how do we get from that? I will come to the part like how to do that. I'm a bit unsettled because I prepared something else. I wanted to give you a larger introduction, but now actually I can go to this. Let me continue. Maybe I forgot a few points in this demo. Notify property change. Another thing that is here in this example is under redo. So if I do a modification here, you can see that I can undo things, I can redo things, which is actually, it does take a lot of boilerplate code to implement these things. But as you can see in the customer model, the code remains the same. And then another thing that is implemented in here and that is hidden basically is that when you click on save, not really visible here, but there is it prevents modification. So there is a threading model that actually prevents your modification from the UI when it is being saved. This is this reader-writer synchronized. So we can apply patterns to business and UI code. Patterns can be observability, like notify property change, undo redo, or a threading pattern like here, reader-writer synchronized. Just one example, we have more things. Actually, I don't have a systematic demo of all of these features, but if we go through all the presentation I prepared, you will see a few of these things. Okay. This is not what I wanted. Yeah, okay. So this was this demo. Now I'm here, and write down this URL because you will all get a free license of PostSharp Ultimate. I find it awkward to do a talk about PostSharp without giving a license. And frankly, I hope you will come back with an order of 5. That is why also. So yeah, take a picture. Please complete the form by tomorrow noon. This is not an automatic. It is half automatic, but please complete by tomorrow noon, because then by now the URL is public, so we don't want to have like an open URL to order 3 licenses. Okay. Okay, so I've shown you that already. So we have the framework. I will show more about that. We have the ready-made things. I will show a little about that. And I've shown a little about notify property change. Actually, in the XAML example, there is another thing. We also have a dependency property. This is in my fancy text box. This is how you define a dependency property. This is how you say that it is required. So in XAML we support that, and we also support commands. So here is, so commands are a bit more difficult actually, because you still need to write more code, but it automatically binds save command to execute save, and can execute save. It creates the boilerplate code to make that work. So this is now a command that supports can execute save, and you do not need to raise the event because it actually uses notify property change, and it sees that when this collection changes, this change, and therefore the command changes. So all the wiring is done by PostSharp, first by instrumenting the code, and then by some runtime libraries. So today I will show you more about how we modify the code and how the whole framework is structured. Oh, which one is that? Now I have 2 with exactly the same slide. I close this one. Bye-bye. Doesn't want to move away. Okay, now this one. Okay, now it's going to be more structured. So I'll write the onion because I would like now to get a tour of PostSharp by starting from the outside as a user, how it looks like to use PostSharp, and going deeper. So the first layer is a user's perspectives, a user's view. So how does it look like when you have a pattern-oriented API? So I've shown you a very simple sample with just 2 forms with a few custom attributes. But actually, when you really think with patterns, and not think with hats, but really think with patterns, you can actually have pretty interesting stuff. And for this, sorry, I'm always confused by these slides. I need to close them. Okay. Yes, so for this, I will show you, so under the hood of PostSharp, I will show you our dog fooding. So we have a user interface that is a plugin to Visual Studio. If you want to see a few com calls, I can show, and you will understand why all these plugins are not ported to Mac. But first, the UI is the thing that creates this menu and enhances the tooltips and so on. So first, let's see what the UI does. I'm switching back to the sample and say, So one of the things we have here, for instance, here we have the full address, and it tells me in the tooltip. Let me try. So no, I need to be fast because when I take someone, oh, okay. So the tooltip is enhanced, and it, basically the UI tells you the full address property depends on line 1, line 2, town and country. So PostSharp UI actually extends Visual Studio with some information about what it understands about PostSharp. That's one thing. If you go here, no, I was not quick enough. Yes. It tells you, okay, we probably save 10 lines of code here with PostSharp, but when you change the country property, possibly full address is already, it's also changed. So that's a part of the UI. Another part of the UI is that we have the list of aspects in the current solution, including the list of targets, so actually you can understand which aspects are applied where and so on. So this is the UI. Now, this is the source code of the UI, and part of the UI is there is a wizard system. When you go here and say, I want to add logging to everything, I want to add logging. So you have a wizard system here. That's what I want to talk about. And as the architect of this, I took a few decisions while designing this code, or actually while refactoring that. This represents a page of the wizard, and I defined it is going to be thread defined, because you have always a problem in Visual Studio. You never know from which thread what is being invoked, and therefore you don't know by default how your code should work from a multi-thread point of view, which means a lot of random bugs if you do not care about that. So here I made assumptions, and I decided all wizard parts are going to be thread defined. Thread defined means they are going to be called only from the UI thread. And I made the decision based on the interface. So I have a pattern, thread defined. I could have a pattern immutable also. Immutable is iWizard, iProgress. Yeah, it is iProgress task. So here is another decision I took from the architecture point of view. I decided that a progress task, which is a task in the wizard, it must be immutable. Any class implementing a task must be immutable. I took this decision because I do not want, so I put this decision here because I do not want to think, to reason about the threading model of every single class. I want to take this decision once, and I want all developers in the team, now and 5 years from now, to actually follow this. The thing is that we reason at the level of patterns. We take the decision at the level of the architecture, and we stop working with read-only themes or locks and so on. So this is actually how it feels when you work with a pattern-oriented or pattern-enabled language, or with a pattern add-on like PostSharp. You can take high-level decisions, and you are saving developers in the team to even have to think about that. So I took this decision. All the progress tasks are going to be immutable, and any progress is going to be reported through the task observer interface, and therefore it should not change the caption, because in the previous version actually the caption was updated, and while changing this this design, I added the immutable constraint or the immutable threading model to ensure that no change are going to be done. Otherwise, I would have a thread like an exception at runtime. Oops. Close app page. Now we are still in multi-threading. This is the code of the installer. This is the page of the installer that displays all the processes that are preventing the installer to execute. And there is an external, so a separate class that looks at running processes. And this event, the collection change from the locking process collection, it comes from a background thread. But this is a UI part, so it is thread defined, and so I cannot execute. So I had to use dispatch here to tell PostSharp to execute this method on the UI thread. If I would not do that, I would have an exception, because we do not allow, like by choice, by design, we do not allow any wizard part to execute on the background thread. So the idea is that you actually get custom attributes that you can use to define how your application should behave from a threading point of view. You define that at the top level, and then you can introduce some tweaks and exceptions. And the benefit is that you cannot have random data races, because actually, if you are trying to modify a field, for instance, from a background thread, with just C#, you are going to have a data race. But when you use PostSharp, you are going to have, in the debug build at least, you are going to have an exception, an invalid thread exception, thread mismatch exception. So instead of having a random failure, 1 on a million, 1 on 1,000, that you cannot test, actually, you have a deterministic failure that you actually hit when doing any test. So that is the value, and this is how it looks like to work with PostSharp. Okay. Questions about that?
How many lines does it take to implement such a dispatch attribute, for example? Is there, I don't know, the level of abstraction that you use when implementing patterns in PostSharp?
Dispatch attributes.
System.
Well,
Dispatch and invoke, right? That's all it is.
Please.
It's just a dispatcher invoke, right?
In case of
that
WPF,
marshalling.
yes, this is what it does. So in case of WPF, it does dispatcher invoke, but it is actually smarter, because if you apply that to WinForms, it is going to do begin invoke, and then if you apply it to something else, it may use execution context dot begin invoke. So when you implement the aspect for yourself, you do it easily, but when we implement that, actually we do that for different contexts. And so, okay, I can show. Pizza is here. That was very discreet.
Secret message.
That was a secret message. So that would be the next thing, is to go. So now I give you some idea of how we use the aspect ourselves. I actually wanted to show you something else. Where is it? Find notify property change. Here is an example where we actually use notify property change. It'd be good to have at least one property. Well, I don't see the property. Yeah, that was not a good example. Notify property change. Yeah, you see all these things here, the properties that you can bind to your UI code. This is all taken care of. The good thing when you delegate to the compiler is that you no longer have to think about that. Like if the compiler does not understand your property, it will block the build. It will say, I don't understand. Please add an opt-out because I cannot understand this expression. Actually, PostSharp tries it actually decompiles your code. It analyzes the expression tree, and it actually detects that this property depends on this property, and that this property depends on the backfilling field, and so on. Here, it's something that PostSharp does not understand because it depends on something it's not understand. But we say, okay, it's fine. This is how we opt out. So this is the philosophy of using PostSharp, and I hope the philosophy of using pattern-aware compilers in the future. I have this hope or vanity probably that in the future compilers will standardly implement this kind of things. But so the philosophy is that you tell the compiler what to do, and then when the compiler does not understand, you tweak. But by default, it works. And when you do the code review, you would focus on things that on the exceptions. Okay, more questions before pizza? I know it's a big pressure on the one asking the question just before pizza. The social pressure. No question before. So let's go for pizza. 20 minutes?
Yeah.
Okay.
Da gibt's keinen.
Das funktioniert ziemlich gut. Ja, fast gestört. Das macht nichts. Wenn du siehst, weißt du genau, was ich mit der Welt mache.
Ja,
Wenn du heute Abend
last time I was here, I was the only one.
fast in meiner Schlaf.
And that happened.
I have a little like a Christmas.
Yeah, I don't know. Yes, it's like that.
So, I never really understood this because programming is an also communicating with other people, and that's really what I'm doing.
Can we continue? Are you ready? Let's continue. So someone was interested in logging. So I'm just going to show you something with logging. So we have one ready-made aspect for logging, and actually we have a complete framework and solution for this. So here is one way that you can add logging to everything. I will increase the zoom level. So you can just, like, instead of adding the log attribute to every class or every method, you can just say, I want to log everything. You could also say that you want to remove, you want to exclude one class. Here we are excluding this class, or you want to exclude namespace and so on. So this can all be done declaratively. And then here is some fake business logic. You see it is just business code, it doesn't do anything. Here there is some logging code, but isn't what I want. And you apply logging to everything, and then it actually instruments your application so that it adds logging to every single method that you want to target. And you can know it prints the value of parameters, it prints the return value. I guess it should be somewhere here. It's able to do like a few things.
What's kind of tracing is not logging.
Tracing and logging I use as synonyms here. What is the difference? Tracing would be automatic, and logging would be manual. Is that what you mean?
Can you configure, for example, that the parameters are not being logged?
Yes, you can configure all that things. I just lost my mouse. Yeah, here, I found it back. Yes, you can configure. There is a file, PostSharp config here, and you actually, in the profile, you say what should be included or not, but like in IntelliSense, I guess doesn't work here, so I don't know how it's named, but you can say that you want the parameter names or not, or the parameter types, or I don't know if you can say that you want no parameter at all. Maybe, I'm not sure. But all these things can be configured, and then you can configure basically everything. You can configure everything. What does it say here? That you can include execution time. You can include the line, the file, and the line where the message is. You can include which task is being awaited. You can also include whether you want the parameter value. I don't know why it is not in this documentation.
There's also a free version of PostSharp, right? Is logging included?
There is a free version of PostSharp. It will work with 50 classes per solution. Currently, there is a limitation on 10 per project that we are going to change. So the free version can be used on small projects, like unlimited time, unlimited number of users. I mean, one, but everybody can have this license. But 50 classes per solution.
Is it working on Mac as well?
Is it working on the Mac?
Yeah.
You can build on the Mac starting from now. I mean, 6.3, the version that is now release candidate. You cannot fully debug on the Mac. I mean, it may work, but if it is broken, you don't have our Visual Studio extension that customizes and adapts the debugging experience. The building works. And you don't have the tooltips and these UI. That does not work on the Mac. So now we support .NET Core, we support .NET Standard, .NET Framework, and that's it, officially at least.
I think we have it running for UWP.
Excuse me?
I think we're using it for UWP.
Yeah, at some point we supported that, but there was so little demand that we stopped. Actually, we had this working pretty well, but the platform was not successful. I guess now with NuGet Core 3, no, NuGet, .NET Core 3, UWP is going to be almost irrelevant unless you want to target the Xbox. So I
Elaborate on that. Why is UWP going to become irrelevant?
Big Phil. Well, I don't know that Microsoft is deprecating that, but Microsoft invests in making WPF
Yes, WPF
works in .NET Core.
run .NET Core, yeah.
Yeah.
But UWP, I don't know. I'm really asking. I don't know. I'm not testing.
Because .NET Core 3.0 basically the main focus is Windows apps application for us.
But UWP is Windows runtime. It's a different thing. So
Yeah, but the idea of WPP was for smartphones, for
Windows Store.
So Windows Store, yeah, but now they will move the Windows Store to .NET and there will not anything.
There's also now already a host that allows you to boot the .NET Core runtime from a Windows runtime host, so you can actually deploy Windows runtime apps and use UWP runtime components on .NET Core. I mean, that's the way they usually work. I mean, if you run a debug, it's already causing harm. But maybe the release builds are going to be like mono AOT builds, but still use the .NET Core.
What about the JavaScript with the VPS and all that stuff they made up? Gonna throw it away?
Yeah, these are not official news. It's just.
Please Blazor for it.
Well, what I can see is that there is investment in WPF, which were not during many years before, and there is no investment in UWP. And in UWP, basically the platforms, like the benefit is that you can target Xbox and the HoloLens, which are now not business platforms. So, and we are mostly oriented to business software. So UWP is not in our priorities. That used to work pretty well, but we had to focus. Okay, but so we have this caching. Actually, it is not built using the framework, the aspect framework I will show later. It is much faster, and it is completely customizable. I mean, any target framework like Log4net, Serilog, or anything, you can create your own. You can customize everything, like the creation of the string, of the text. Even you can log to an object database instead of a list of text things. It is completely customizable. You can do funny things like if you don't want, if you don't like how the integers are formatted, you can basically plug your formatting of everything. So this is very flexible. That was just a few words. More questions on that? Before I jump to the, like, how do we do actually aspects? So I will then go to the next thing. How do we implement aspects? Excuse me?
Oh, I thought there was a question.
Excuse me, I don't hear well. I probably have flu or I don't know, but I'm not in my normal state, and my ear are in a strange state, so I don't understand everything you say, and maybe I'm telling strange things. Okay, so the aspect framework. So the aspect framework is basically, a kind of it gives you Lego bricks, and from the Lego bricks you build your own aspects. So it provides primitive transformation, and you can use these transformations together to create something bigger. For instance, when we implement notify property changed, basically we need to introduce an interface, the iNotify property change interface. We need to introduce the onProperty change member. We need to intercept field setters. You also need to intercept methods, but that's another thing. But so the idea is that any pattern can be expressed as a set of transformations. And these transformations are provided by PostSharp. So you create an aspect by telling, add this interface, add this method, or override the existing onProperty changed, intercept all fields. So this is how it works. So let's take one example. It's non-method boundary. So when we analyze or we reason about aspects, it is good to make a difference between the method and the method body. The method is the thing you call. The method body is the thing that it actually executes. Even the C# compiler makes this difference because, for instance, the method of enumerator or async method, it's actually this method, but it contains two lines. One is to instantiate a state machine, and the other is to return it. So actually, that's just one line. So the method body is moved to a different class. So we use the same concept. So when you add an onMethod boundary, it means that you can react to for events, actually more with a thing, but on entry, on success, on exception, on exit. What it does basically is that it adds a try-catch finally to your method body, and it injects calls in the aspect. So your aspect code is not expanded inline into the target method. We actually call your aspect, which is why the method needs to be public, for instance. So this is on method boundary, and an example of that, the most annoying example of all is logging. It is so annoying because it is the hello world example, but it seems that many people stopped at the hello world example and believe that AOP or PostSharp is logging. Well, it is not only. So here is an example where we have on method boundary. So we have an aspect that logs method, and we want to log entering, success, and exception. So we create a string builder, we append entering, we append some code information. Here we get the context. So the aspect itself doesn't know at build time, you don't know to which method it is going to be applied. So how do you know? This is a runtime information, and in this API, it is given to you as a method execution args. So here in this append code information, I can get the method, so I get reflection about what is happening. And so I can append the type name, the method name, the generic arguments. So I have the complete context, and then I have the array of arguments. They're not generic arguments, but the arguments passed to the method. So this thing, args, actually contains the context. When you create your aspect at design time, you do not know exactly to which method is going to be applied. And this is it is a design principle. I've seen some customers would make one aspect per target class. This is not good practice. You should, like when you do an aspect, it should apply to, I don't know, at least 10 classes. Otherwise, it doesn't make sense to write an aspect for 2 cases.
What is the formatter?
Formatter, which is some code just to make the example a bit more complex. That's because I reuse this code from another. For instance, if you want to set to log setting of a field, it could be important in debugging things. You want to log setting of a field where I reuse a formatter. Here is an interception. I will talk about that a bit later. And so I say these are the arguments of the property. If the location can be a field or a property, and a property can be an indexer. So a property can have arguments, so I format arguments. And then I say equal, and I say that I write the value. So this is good to show how it works. That's a terribly boring example, but it's very, very good to actually show how it works. And here it is applied to the famous Fibonacci method. So now, going from that, I wanted to show you what it does with your code, because this talk is still code under the hood of PostSharp. So under the hood, you should see something. Reflector is fine. Custom logging, so we added logging to Fibonacci. Fibonacci. Okay, so let's look at the original code of Fibonacci, PostSharp samples, program, Fibonacci. This is it. That's the original code, and this is the code. So what PostSharp does is that it calls on entry here. It instantiates the context object. It assigns it to.
Can you enlarge one?
Yes.
Okay.
So it calls on entry and it provides the arguments that are necessary for on entry. Then at the end, it calls on success. And if there is an exception, it calls on exception. This is because you asked in your aspect, this is what you ask. You ask on entry, on success, on exception. So PostSharp does that, and it provides you, it fills the context argument with what you required. If you did not require the method info, it would not give you, for instance, some optimization. So that's pretty simple. Every competition of PostSharp is able to do that. That's simple. Questions before I move? Okay, method interception is a different concept. So instead of adding try catch to the method, we actually want to intercept. Then we can do whatever we want with that. We can call it or not, call it from a different thread, call it 5 times, you decide. So when you add an aspect with, so an interception aspect to a method, what it does is that it creates what we call a binding class. It seems that my animation is broken. And it moved the original method body is moved to the binding class, which is something close to, something similar to closure classes or to that you have when you do anonymous methods or to state machines. Basically, it is a compiler-created class, and the original method is replaced by a call to your aspect. And a good example for that is auto-retry. By the way, all these examples, you can find them in GitHub. You do samples.postsharp.net, you get all the samples. There is a link to GitHub. You can test it, download everything. So auto-retry, let's look at that. It is method interception, so my main method will be onInvoke. And this code will be, this method would be called instead of the thing I apply it to. So here I'm going to apply to download file. And I'm going to show you the debugging experience. And for this, I first need to make sure that it is the default mode. Yeah, this is the default mode. So let's do step in 2. Yeah, I didn't show you how. So I've shown you the aspect, but then you still need to apply the aspect to something. And the aspect is where there should be something here. The debugger stole my screen real estate. Yeah, so here. So basically, there are many ways to apply aspects. One way is to apply to everything, or almost, which makes sense for logging, but it would not make sense for auto-retry. For auto-retry, you probably want to apply to specific methods, or to methods of specific types. So here we are going to add auto-retry to download file because we may be on unreliable network, for instance. So let's continue. I'm doing step in 2, and you see I stepped into the target method. You do not see. I will do this. The call stack here tells you that we have intercepted this method. There is some aspect. So by default, we take the assumption that the developer does not want to debug the aspect because it has been done properly. That's the default behavior, but you can change the default behavior. You go to options and you say, I want to step into the aspect. It is not the default because typically developing the aspect takes a fraction, 1% of your time, and most of the time you are going to use the aspect. This is why PostSharp is more productive. Okay, so now we are inside this. And we will, okay, we should have some network failure. So I made it random. Okay. So now I'm doing step in 2. And you see here I'm back in the method. Okay, now if I want to actually debug the aspect itself, I would go to PostSharp options and I would say I want to step into the aspects, and I'm an expert. I want to have the real call stack and not the predefined call stack. So let's go here. We do step into here, and now we are inside the aspect, and you see the real call stack. I'm going to remove the module name. That's not useful. Now you see this is now the real call stack. We are inside on invoke. This is actually what we did with your code. So let's step into the aspect. Okay, we proceed. When we proceed, we go to the real method, and you can see here the code. No, I need to go there, and then I do. This is what we've done with your code. We added things, so now the original method is in a different class. Okay, so now we can go there and wait for a failure. Ah, success. Well, I wanted a failure, too bad. Okay. Well, if there were a failure, we would retry and so on. Something we do well is that we actually do understand async methods. So when you have an interception method, what do we try? Yeah, here there is the implementation, the async implementation, and as always with async, unfortunately, you need to copy paste the code and change that it is await. That is not something we have influence over. It is C#, but yeah, but like PostSharp allows you to have different signatures, and PostSharp will choose the right signature. So currently, we support on async, on invoke and uninvoke async.
How about an async aspect?
Excuse me?
How about an async aspect converts all your synchronous code into async?
That would be good. Actually, well, this is kind of challenging. If I didn't run a company and had 5 kids, I think I would spend a few weekends trying to do that. Yeah, I've been thinking about things we could do because this is terrible. No, with the new Visual Studio, the 2019, there is async initialization. They are very proud about that. Well, it's a big thing actually. But no, imagine what it actually means. Async initialization, it means that to get a service from a service provider is an async operation. So now within Visual Studio SDK, if you get a service from the UI thread, you block the whole UI thread for 5 seconds, 10 seconds, because you actually require the whole Visual Studio to be initialized asynchronously. But so anyway, so that means that your whole code becomes asynchronous because basically you have an asynchronous constructor which does not exist. So you need crazy tricks. And this is horrible. So we spent 6 weeks of just moving sync code to async code. That was six programmers week to do that, and an aspect would be nice indeed. And it is more than what we can do now. Okay, so this is what we do with the code, and now, well, this is how it sounds. I want to open this. Open file, yeah. That is it. Bin debug. Let's look at the auto retry sample and copy paste. No, not for. Auto retry program. So here is the download file. So now you see, instead of calling your method, we are calling the aspect, and we are assigning like the context to the thing that represents the original method. So that is the binding here is the thing that actually invokes the original method. So here is the original method. So we need to create a binding class to represent the method as something that to represent it as an interface. So we don't need to use delegates that have all kinds of problems with this case. Okay, that's what we are doing with the code. So that my marketing manager Dagmar is happy. I need to say that. No, but not yet. Actually, like all frameworks can do a method boundary and an interception. This is the basic. Everybody can do that, but we have really a lot of engineering in supporting async properly. This is something you are not going to get done well from an open source project, because these are hundreds, I believe even thousands of hours. Getting async working properly is very difficult. Okay, so what I've shown so far is a simple API. There are two APIs in PostSharp. One is the simple, one is the expert or the composite one. The simple means that one aspect has one transformation. You have to choose which transformation it is, and you have to derive your aspect from the primitive transformation class, primitive aspect class. It is based on interfaces, virtual methods. It is easy to learn because it uses object-oriented programming, paradigm, and analogies. Now we have another API where you can combine several transformations in a single aspect. So when we implement notified property change or immutable, actually this thing is done from several aspects. And because this presentation is called Under the Hood of PostSharp and is really for hard code stuff, I will show you how we implement threading models. So I've shown you how we use threading models in Visual Studio. And I've shown you, for instance, immutable and thread-define. So let's go to thread-define. Move away. Thread-define aspect. Thread-define attribute. When should I stop, actually?
When you're finished.
Well, no.
But
I'm
perhaps
going.
today.
Okay.
So we have contact till midnight, actually. So. oh.
I think that the metro, the last, is about 11:30. But
Okay.
No.
no.
I don't know. We're using
No.
only.
I cannot be finished. No, I've been doing that for 15 years. I could talk about that. Okay, so this is thread-define. So you see, thread-define is a class like object-oriented. But the important thing is that it gets all the features from thread-aware. So thread-aware is something that understands threading. This is what it means. And here threadify says that, so there is a design where every object is assigned a threading controller. The threading controller implements the logic. The aspect calls the logic. It actually changes, it injects hooks, and it injects logic in the target code to call the controller. So a thread-defined controller is something that it is probably the easiest, is when the owner thread, the thread that created the controller, is different than the current thread, then we throw a thread mismatch exception. We have similar logic for a synchronized controller. Where acquiring, we would acquire a monitor, so a lock. When we acquire reader-writer synchronized, we would acquire the right lock level. So this is done in a very object-oriented way inside the controller. Now let's go back to the aspects, how the aspect is implemented. So this is what you have here, all these things, something I used to be very proud of that, but when I see how many lines I need to write, I'm no longer. But anyway, this tells how the aspect should be ordered with other aspects. So now, in an application that uses PostSharp, you could have on a single class 5 aspects. PostSharp has been designed for that, and that works nicely, but you need to say in which order it needs to be done. This is it. This says that the aspect is inherited, so when a base class is thread-defined, all derived classes are going to have the same threading model. That makes sense. And this means that we are going to introduce the iThread-aware interface that basically exposes the concurrency controller. So we will introduce the interface. So what else will we do here? We need to intercept field setting. So let's look at field setters. There is a lot of code. Fields. This is the code to intercept fields. So this is the logic that intercepts accesses to fields. Here, this is an advice. You see, it is no longer an override of an interface or an implementation of an interface. This is actually a method, and PostSharp interprets that as an advice because we have the onLocation set value advice that tells PostSharp that it should actually intercept field set operations, to which method it should be applied. This is answered by the select writable fields method, which is here on the top. So basically we have some logic that analyzes the time based on reflection. It looks at the field, it looks at the methods, and it realizes, okay, here is the list of fields that we should advise, that we should instrument for writing. So the thing you see here, the binding and this is the new API for writing high performance aspect that is not yet documented and that we use only for internal aspects. And we plan to make this public and to test it properly. It is tested, but only for the scenarios where we use that. It is not tested in general for now. So, and the benefit is that you actually get all the context information like the current instance or the value of the field, you get that on the stack, not on the heap. So there is no heap allocation needed here. Okay, so when we set the field, we use the threading controller to require access, to require write access to the field. So if I have a synchronized object, which means everything like synchronized means that we are going to acquire a lock when we open the method. I'll show you that with methods we have the same thing here. On method entry we acquire access. So if we have a synchronized model, when we open a method, when we enter a method, we would acquire a lock, and then when we write a field or read a field, we would verify that the current thread has owns the lock. If the current thread does not own the lock, it means that you did something like task.run this.myfield equals, that you are trying to break the model, and we detect that, we throw an exception. So back to how the aspect framework works, you have advices here that you define using advice custom attributes, and you define using a method point cut. This custom attribute says that this method here, which is executed at build time, is the thing that analyzes, like that returns the set of methods that should be instrumented. That's kind of the philosophy of the low-level framework. So this code runs at build time. It is very powerful, extremely expensive feature to maintain, to make sure, like to give you the ability to run your code at build time. You can actually run any code within the compiler and to modify your own assembly. Basically, what you are doing is that when you write an aspect, you are writing code that runs inside the assembly, that runs inside the compiler. It looks at your assembly and it gives to the compiler the list of transformation to be done. This is how PostSharp works. And here you can do like any reflection you want. You can use other PostSharp APIs at build time, like the aspect repository. So for instance, what this does is that this aspect relies on another aspect, so it asks the aspect repository if the aspect is there. If not, it will add it. So you can do pretty complex things. You do your analysis, and then at the end you provide the transformations. Question?
You were talking about throwing an exception if it's the wrong thread.
Yes.
If that's during compile time or during runtime?
This is during runtime. So PostSharp cannot do well. It cannot do, I would say, complex static analysis. There are basically two types of static analysis. One is that you have straightforward algorithms that run once, and then you have fixed point algorithms. Fixed point algorithms, they are used. I can give you an example. How can you know that a method is called? You would follow the call tree. So this is easy. But how can you know that a method is called if there is a virtual call or a delegate? So now it is no longer enough to analyze the calls tree, because you need to analyze the data flow, because according to the data flow you are going to have different code and different flow. This is possible to do, and there is software that is able to do that, but it runs during hours, even days. And this needs to run within seconds. So what PostSharp is able to do is this kind of easy static analysis to look if a field is instance or static. What is the type? What are the fields and so on. This is the easy one. And I hope it would be possible and economically feasible to analyze. to interpret the execution without actually executing that. It is theoretically possible, but we don't have that. We don't even have nearly the budget to implement that. It looks like high dream to do that.
Threat affinity is not guaranteed by design, but it's checked.
It is checked.
But
Yes, it is checked, but it is checked in a deterministic way. That means that if you have a single threaded code coverage, or if you get your test using an instrumented build, well, they are guaranteed to hit the exception, and you are guaranteed to get your developers fix that. With comparison to getting your field changed by another thread and having a data corruption and a probability on a million or 1 on 1,000 to get the error, because then you do not get that during testing, it is not reproducible, and you get the exception in production, which is not what you actually want. So our approach with threading is to be deterministic, to fail deterministically. We are not able to analyze at the time. Not much. Like we can't say things that you cannot have public field because it cannot be instrumented properly. That's what we are doing here actually. You cannot have public or internal fields, so we write message. That's the most complex thing we are able to do. Almost. More questions? Do you get an idea of how the aspect framework works?
if you're done with the threading affinity, you were talking about immutable classes before, and all we've heard up to now, it affects sort of the behavior at runtime, but immutability affects the behavior at compile time. How does it integrate in Visual Studio and the compiler? Do you get compiler warning if you try to mutate an immutable object? Or?
No, actually, we define immutable as being like you cannot modify a field or a collection after the constructor has completed.
And it's also a check at runtime.
This is a check at runtime, but in theory, you can, within your constructor, you can pass an object, your current object being constructed can be passed to a different thread. Like C# lets you do crazy things. And these are the things that we would verify. We would verify that two things actually. Before the constructor has completed, it is not being accessed by a different thread, which is not likely for immutable, but actually immutable for us is a subcase of freezable. So let's take freezable. How do we enforce freezable? Is that before you call freezable, you cannot access the object from a different thread than the thread that created that. And after freezable, you cannot modify. So before you cannot read and you cannot write, and after you cannot write, but you can read from any thread. And so now for us, freezable, immutable is actually just that we call freezable when the topmost constructor completes.
So before, I also saw an attribute naming convention.
Yep.
Asterisk stars. Such an attribute, is it verified compile time or runtime too?
This is a compile time thing. So we have these. I didn't talk much about that. Actually, not at all. But
it's obviously a very simple concept.
Yeah.
I was interested in the integration during compile time.
This is really this is a compile time thing because this is basic static analysis. We have a few constraints. So, for instance, one of the constraints is internal implement.
And then you get a compiler error, just like
you get a compiler error. Actually, you can do interesting stuff. Here is an example here. I have a manage resource with string 1, 2, 3. a nice source code that has like references to these strings, and I want to validate that this is a valid resource name, for instance. So this is an invalid because I wrote strong. And actually, you can create code that that validates that. You can do that. You know, we take the resource manager. Where is that? No, this is it. We take the resource manager. We go to all methods, calling that method. We get the expression tree for the method body. We have a visitor on the method body. We visit any method call. When it is a call to the method, we are actually verifying. And this is a constant. Then we can write an error message to the compiler. So this is already the pretty complex thing we can do with static validation. But it is still a forward algorithm, not a fixed point one. Okay. Did I answer your question? Okay. More questions on the aspect framework? Like this was mostly a question on threading, which I tried to focus more on the aspect framework one. Yes.
When you specify a point cut for example, for some wildcard names, a specific set of names.
Yeah.
Does your compiler, does your aspect beaver go through the whole code, or do you have some kind of index representation of this code?
There is an index representation.
I don't know the performance hit on the compilation time.
Well, first we would match. Well, if you do. Well, if you do that here, I mean, inside the aspect, if you have, within an aspect, you have an advised point cut, we would actually need to go to all methods of this type, but we would start with the predicates that are cheap. For instance, if you ask only public methods, we would first check the public method predicate because it is cheaper to evaluate than a regular expression.
Okay.
Actually, reflection is much slower than PostSharp itself.
Okay.
So actually, when you use reflection from PostSharp at build time, you may be slowed down by reflection engine. Our own implementation of reflection is faster, but actually we do not expose that. Well, that's something we could do in the future, but currently not.
Thank you.
Okay, so that gives you an idea of how you create your own aspects and how we create the aspects. And what I've shown you is already pretty advanced. There is some theory behind this. Actually, I tried this talk to be a bit geeky, not to be just like showing useful stuff, but also showing cool stuff that it is useful, but not directly for you. So inside PostSharp, there is a pipe and filter analogy with still this broken animation. It was developed by the University of Twente in the Netherlands, but when you have a property, a semantic, like a method definition, a property definition, and you have an implementation, we actually consider that as being a pipeline through which two messages go. The first message is the request, set the value or get the value, and the next is the response. And so we actually put filters, so your aspects are filters there, and I guess it will be, yeah, this is the craziest animation, but I did that, I don't know, 10 years ago, and it still works a bit. Okay, so this is the get message. Here I didn't implement the getter. You see, you could have aspects that make sense on fields and properties, but on the setter, additionally, you could have a method level aspect, and this all works because we follow this analogy. It's very important in PostSharp. Like, PostSharp is a very, very low level thing. We actually work with MSIL, with bits. It is terrible. To make that understandable, we need to have analogies to make that like possible to reason about that. That's a crazy animation. One of the first I did in PowerPoint, I guess. Okay, so here we have a clear model so that you can really reason about aspect composition. So when we have many aspects of the same transformation, we create actually a graph, an oriented graph for all transformation A, B, C, D. Some relationship could be ordering. You could have a requirement. A requirement maybe, for instance, thread-aware requires aggregatable, because thread-aware, like the children object of a thread-aware object, needs also to be locked. Therefore, you need an aggregatable, like a child-parent relationship. So you can do things like this. Commutativity means that two aspects can be ordered in any order and conflicts. For instance, you could have oriented conflicts or unoriented conflict. An oriented conflict could be you cannot have caching before authorization. Caching must be done after. It is not necessary to have authorization for caching, but if you have caching, it must be done before, after authorization. So you can express these kind of things. So the pipeline is that the user of your aspects, they put custom attributes typically. They use custom attributes. They use wildcards to apply to whole namespaces in case of logging or multicasting or things like this. Or they may use aspect provider. But the attributes, they provide aspect instances. And so aspect instances, they define a set of transformations that we call advices. They are the simple aspects, they are the expert aspects with more transformations. They define point cuts. And at this moment, it is still unordered. We still evaluate aspects at this moment without specific ordering. But then we build for each, so we build a map of all transformations that are required by all aspects. That means that for each declaration, for each type method, for each anything in your assembly, we have a list of transformations that may come from different aspects. And this is this list that we need to sort every time. So inside PostSharp, we have a kind of a chain of responsibility. Actually, internally, we call that matryoshka, because the first aspect is responsible to emit its own code, and then it emits a placeholder for the next transformation. And it calls the next transformation with, okay, please inject your code here. But actually, every aspect can move the code to a different part. It can create a new type and say, inject your code here, but actually this is not the initial type, it is a nested type. And so we have interesting things like that we have a virtualization of parameters, for instance, that what used to be a parameter could be now mapped to a field and things like this. And it is all very nicely abstracted, and these abstractions make it possible to build complex things with a lot of aspects. So I wanted to show here some very small part of this aspect ordering, maybe like an interesting thing for you to see. Where is that? I didn't load the solution. Actually, we have a class we have 3 classes that just do a topological sort. And we have one version that is object-oriented, that it works with a general graph of arbitrary size. And then we have one version that works with 32 nodes and one version that works with 64 nodes. And I wanted to bring this curiosity because this is a way to optimize the algorithm to fit with the CPU cache. Like the topological sort is critical for the performance because we need to solve for 10,000 of types or methods. So we have these general. So we have the abstract graph. And here you see we have 3 implementations according to the size of the graph. And we do these optimizations actually to fit with the size of the CPU cache. So I believe that's kind of interesting to see that when you are in performance critical parts of the code, you can actually write the same code twice or 3 times just to optimize speed. So we have even these kind of crazy things. Yeah, questions? Okay. Now we are reaching the end. Well, the end of the technical part, but I don't know how much I will still have my head for the rest. So this is approximate, very roughly, and this is the architecture of PostSharp. What happens when you run the code? Here we are really under the hood. So there is an MS build task that is responsible for instantiating the process, so starting a new process. So PostSharp has this ability to run the current assembly. So we actually run the assembly being built, even if it is built for a different platform. We actually can run it. It's a bit crazy. It's a very expensive feature to maintain, but it's very useful. So we do that. So actually, this task is not trivial. So we start PostSharp, and now we are inside the PostSharp process. We have a project loader that basically it looks at what needs to be done. There is a service locator and a service discovery. So it would look at the assembly and figure out all the things that need to be done. For instance, load the aspect weaver component. So there are different tasks in the pipeline of the project loader and executor, and this is auto-detected based on the configuration file or based on custom attributes within the assembly. So, but in every case, the first step is to decompile the assembly. So for this, we have our own MSIL reader. And the output of the MSIL reader is a code model. So we represent the assembly as a code model. And then the project loader, after this is the project system, then after this is loaded and parsed, it runs the components. The most important is the aspect infrastructure. This is the thing that is going to take the custom attributes in your project, and is going to look for the transformations, execute the transformations, and so on. So these transformations are all done at the level of the code model, and then at the end we rewrite the assembly and PDB file. So this is a very simplified. We have more services, like we have some decompilation services to understand the C# code or the VB codes. the compiler services and so on. I've gone through that. I don't know who is interested. Like, it's purely useless, but maybe someone could be interested in showing how you can in seeing how you can extend the debugger. Someone wants to see that?
Yeah.
Okay, so I will show you how we extend the debugger. So there is a debugging API that is called Concord. Sorry for your eyes. I'm going to switch back to something dark. Yeah, Concord. Concord is an API for it's the Microsoft Debugging API, the Microsoft Debugging Extensibility API, and there is this concept that you create add-ins, and your add-ins register filters. So here there is a service that is stat complete received. So actually I want to, so I will register to the event or to the processing of a stepper. This is one thing, and here I'm not sure what it is, but there isn't. But so basically, there are two things that we do. It is to customize the step into experience and to customize the call stack. So customizing the call stack is probably the easiest. But this is kind of interesting. I don't know if I can find that. Actually, it's a long time I have not worked on this code. I did a prototype, and then I said, yeah, complete that, and it lasted 1 more year. I think Stack Walker, I don't know if it is that, but okay. But basically, for the Stack Walker, you get basically a view model of the stack, and you need to return another view model of the stack, so you can remove frames in the stack. You can rename that. Like the call stack you see is it's a view model basically, and so they have the architecture to instrument the view model. I'm just not sure. Call stack. No, yeah. This is on the client side. Yeah. So when you extend the debugger, you can run code on the client side. This is where your process runs. And you can run code on the server side. This is where your debugger runs. And Visual Studio Debugger has some logic to actually automatically upload your server libraries to the process being debugged. So when you debug .NET Core process, for instance, well, the process is .NET Core, but the debugger is still .NET Framework, is still in Windows, C++. So actually, these two things are like separate. So this is why we have two DLLs, one that is uploaded and the other that remains working on your local the debugger. Here is the service that filters the call stack. It implements ID key and call stack filter. And here is an example of the logic. So basically, we inspect the call stack and we create a new one. I'm not going to go to details because I don't really know the details, but like it's kind of interesting. Now the stepper is completely crazy too. Well, call stack was pretty easy. So when you do step into in Visual Studio, it's interesting to see what is actually happening. Well, basically, step into is a UI feature. There is nothing at the hardware level that is called step into. The only thing that exists is a breakpoint. So in Visual Studio, you can think there are two kinds of breakpoints. One is the breakpoint that the user breakpoint that you can actually see, but behind this there are the system breakpoints. So what happens when you are in a method like download file and there is an aspect on that, and you do step into? When you do step into, the first thing that Visual Studio is going to do, so they actually do a run to the next breakpoint, which would be the next sequence point, so the next user code. So actually, Visual Studio would actually stop within the aspect. And so what we do here is that we have a filter, step complete received, on runtime breakpoint received. This is where we are. And we will see, okay, now we stop there, but we are inside an aspect, and the user wants to go to the intercepted method. So what we are going to do is to set a breakpoint to the intercepted method. Even if there are 5 aspects on the way to go there, we are setting a low-level breakpoint, and we are going to do continue. And then this thing is a state machine, and then it's going to stop at the next thing, and then all filters in the game can vote. Should we continue? Should we break? And this is actually how steppers are implemented, like state machines that work over low-level breakpoints. So if you say continue, actually the UI is not updated. You still believe that your program is running, even if it actually has been intercepted by the debugger. Like at low level, there are still breakpoints. Some of these breakpoints can be handled at the server side. So when you want things to be fast, you need to implement the breakpoint handlers at server side, so they do not cross the process boundary. Otherwise, it crosses the process boundary. It goes to your client side breakpoint filter, and it's lower. So that's the easy part, and then when you have async stuff, it becomes more complex because the breakpoint actually can be hit by a different thread, and you need to correlate all things. So you see, breakpoint manager, you can suppress the events. You can send information from one filter to another. So this is how it looks like inside the debugging extension. Questions? I don't expect that to be useful to you. Yeah?
How can you find out that this exists? I mean, I guess it's documented on some Microsoft.
It's kind of documented. This is called Concord API. Well, so it is my job to know it exists. Concord API. This is this thing, Concord extensibility. But so basically, it is documented, but at a very low level or like high level. You need to run like trials and errors. We spent a lot of time not having a testing framework for that, and then finally we found a way how to test the debugger extension.
I wanted to ask this, how do you test yourself?
Yeah, so we install an extension to Visual Studio. So there are two instances of Visual Studio, the test runner and the tested. So
it's a lot of
on the tested Visual Studio, we install an extension. The extension exposes a WCF service, which exposes the debugging engine from from a high level. Like, so you have methods step into, continue, set breakpoint. These very high level things you would do with the UI normally. This part is easy to do because it's available from like a high level API. So it's really just mapping step into WCF to step into in this API, DTE. So from the, I don't know if I can see, from the unit test we call step into, and then we assert that we are at the line that we expect. Not sure if I would be able to find this quickly. I guess it's going to be in private test, and then I guess it is in debugger test. Yes. This is the debug app. This is the debug remoting client. So this is the interface that the unit test is consuming, like open solution, closed solution, go, step into, step over. And now let's go to a specific unit test. This is the test class. No, this is not the test class. This is the thing being tested. Here you see this is code being tested, so there are markers. And now unit test base, debugger init. I don't know it well enough, but method run. Yeah, so here is an example of a high level test where we run this method, and 3 times we do F10, and then we assert that the current method is there. We can assert that that a label, like a comment. So we created a test framework for that.
Can you show method run also? Step into
what's this?
Can you press F12 on method run?
F12.
Yeah, I mean just go to definition of method run.
Ah, yes. I don't know if this works in. No, it doesn't work. Because I didn't load the solution, but it was in unit test base. So run method, it runs each step. So if you call it here, run type is going to be step into, step out, step over, basically the keystrokes. So when we write tests, we need to like simulate these keystrokes to see where we land, or we can do assertions on the call stack. I think not many companies in the world actually implement debugger extensions. Yeah.
I guess it takes more time to write the test code than the actual code in this case.
In the case of PostSharp, testing is more time consuming than writing the compiler itself, or yeah, well, the testing infrastructure is very, very demanding.
Do you also inspect kind of the outcome DLLs, or are there other tricks?
So we have a testing framework for we have a testing framework. I think I could load it. It is. I feel I'm getting tired and I'm slower. So this is PostSharp.test runner, I guess. Small test runner, this is it. So this is where is that? Small test runner exe. going to take. So our main test base for the compiler. So we have two different systems to test the patterns, the ready-made patterns, and the compiler itself. For the compiler itself, we do not use a lot of unique tests. We do use slice test. I will show you. So these are the tests for the aspect framework. It is for import members, and here is one test. Here is one specific test for import. So we import a member, and what this test does is that we expect the message LA00 or 82. So if I run this test, I'm supposed to have this error, because actually I'm trying to import an event called my event. The aspect is here, and the event is not defined. So this test verifies that that PostSharp failed with a specific error message and no other error message. And so this is a typical test. Here is a test that it verifies that like PostSharp should work without warning or error. So it should produce a valid assembly, and it should return 0. So we test aspects by having the aspect do some side effects. For instance, the aspect would append something to the string builder, to a string builder, or would increment some field. And so we execute the aspect and we test for the side effect. We do not do reflection, like rarely do reflection over the assembly. Sometimes we do that, but it's not the most useful way. And for patterns, where it's basically a runtime logic, and the compile time logic is supposed to be tested by the compiler test, but so for runtime test we use normal unit test framework, Microsoft test.
And PostSharp itself is a plugin for Visual Studio. What exactly is it?
So PostSharp is there are basically two plugins. One is to Visual Studio. It uses the Visual Studio SDK, and but most of the functionality is an MS-build plugin. So inside the NuGet package, there is a target file that adds a compilation step. So we inject ourselves after the C# compiler. Yes?
You previously mentioned that you are able to basically load the compile assembly into the MS build process?
No. No, we do not. In the MS build process, we just create another process. And we also have for .NET Framework, no, not .NET Core. We can reuse the process. So we have a pipe server, and the same process can be reused for several assemblies. We don't have it with performance.
So you can also deal with IL, which is now only loadable in like .NET Core 3, like interface members.
We haven't started. Yeah, we started, but it is not released. But that's a good point, actually. In the past, we were able to release RTM versions with that corresponds to the RTM Microsoft features. But Microsoft has release cycles, like release candidates of 6 months, 9 months. It was like quality was high and pace was low. But with the new pace, the quality went low. They break release candidates. They don't even care about breaking things. And we do not even try. We do not try previews because it is a loss of energy. So now we are targeting, like we try to be ready 3 months after RTM. We would look at release candidates but it's not possible to be ready. With .NET Core 3, the release candidate was in the beginning of September, and the RTM was September 23rd. So say there were 3 weeks of RC. Like 5 years ago, there were 3 to 9 months of RC.
I mean, that's an interesting thing because officially they told that Preview 7 is like a release candidate. And I think they mentioned they only called it RC because they could not use Preview 10 because it would be less than Preview 9 for semantic ordering.
So we had to.
I think JetBrains did the same. I think they didn't even look at like C# 7 point something, like 2 months after.
Well, it is no longer affordable. I think we spend at least 50% of developer resources, at least, maybe even more, just to keep up with the new Microsoft features. It is at least 50%, without actually adding features to all products. And this is after adjusting to the new pace. That means ignoring previews. But this is the new way of writing .NET. It's really changed. Like 10 years ago, it was super stable. It was slow, and you could really build on a stable ground. But now you are building on a moving platform, so the whole ecosystem needs to adapt and just consider release candidates as previews, alpha actually.
Do you use PostSharp in the development of PostSharp?
Yes, but only for the Visual Studio extension. Yeah, not for PostSharp itself. Well, first because when I started, there is the chicken or egg thing, so PostSharp did not exist before I started PostSharp. And currently, we could use in theory a previous version of PostSharp to run the current one. Actually, we do use the debug build to run the release build, but it is just for obfuscation. And then there is another thing is that we instrument unsafe C#. So when you use pointers like unsafe pointers, we use unsafe pointers a lot. Like the MSIL stack is written intensively with unsafe code. But we have an internal validation system where we actually validate so that we do not corrupt the managed heap, which is pretty difficult to validate. So what we do is that we instrument indirect stores instruction. So when you change the location of a memory, basically the unsafe memory check, we instrument that and we check that it is in a safe memory segment. And when we allocate unsafe memory, we need to add that manually, like with an API.
In what languages? Is it C# or low level?
This is done in C#. Yeah. It's useful when we have data corruption. We didn't believe it is useful enough to turn into a product. And it's pretty simple actually. We have a dictionary of safe segments, and whenever there is a write instruction, we check that the address is within safe segments of the heap. So I feel I'm getting tired, and actually it's getting almost 9. I have a last thing. Well, in theory we can continue more, but I'm a bit. The last thing I wanted to show you, because as .NET developers you do not see often this data. So we have data from our CIP. So when you opt in for giving feedback, we collect feedback about which .NET version developers run on their machine, and this is about which version you have installed on your development machines for you PostSharp users. We can see that the pace of rolling up, rolling down, that is like a new version is actually getting faster and faster. Here this is version 4.7, 4.7.2. 4.7.2, it was rolled down in actually. What's interesting is to look at the half time, like the time it takes to get to 50% of usage, and you see Microsoft got it in just maybe 6 months. But this is the version installed on developers' machine. But now these are the versions that developers target, and there is much more inertia here. So when you build APIs for developers or tools for developers, keep in mind that there are still some 8% or so targeting .NET 4.0 or lower. That means before async. And actually, it is actually more than any new version. Like by definition, it is more than any new version of any new technology. So it actually still makes sense to support these guys. So there is much more inertia. This is .NET 4.7. You see only maybe 20% targeted .NET 4.7 at the end of June. So, and these are the version that people run on of the version of PostSharp that people run on their machine. You see that there was some data issues during these months, and I guess we fixed some data issue here, so we got more data. And it follows more the curve of adoption of developers for target frameworks than the curve of a native framework, like Visual Studio version. So these are the things we need to watch before taking decisions of taking new frameworks or removing. Questions to that? Okay, well, for the rest, I would leave it open. If you have question now, ask. Otherwise, it's pretty much all I prepared. I think I still have energy for, I don't know, 10-15 minutes, but if you don't have questions, we can finish now. Ask about anything about running a software development tools business. You can ask, I can refuse to answer.
Why did you? Sorry. Go ahead. Why did you move to the Czech Republic? Was it to private reasons or was it to reasons of the business?
A woman, yeah.
It's not about finding technician employees or something.
No, but actually so I moved for a private reason, but I believe that the reason I was able to kick off a company with my own financing, it was because when I created the company in 2009, well, the cost of living was pretty low, actually the half of now. And so actually I financed PostSharp on doing contracts for Sweden. So I could do contract 3 days a week, and 3 days a week I would work on PostSharp. I believe if I stayed in Belgium, I wouldn't be able just to finance the company up to the moment where I could launch a commercial product.
So how many companies out there are using this very low-level APIs from Microsoft's compiler and so? What do you think? What is your guess?
The very low level, that means debugging API
Debugging
and
API,
Roslyn
so on.
APIs.
I mean, it's a niche, right?
It is. It
And
is.
it's super complex.
It is very
and
low.
it's super exhausting. So is it worth the effort for Microsoft to supply with such an interface? Does it cost Microsoft more money than you to implement and use it? What do you think?
Well, like Microsoft doesn't do it for us.
I know, but in general, right?
Well, the current strategy of Microsoft, I cannot talk for Microsoft, but this is what they say, that they want to support any platform. So what they're doing is to release an API that actually allows people to implement Visual Studio support for Python for all these platforms. So it is a part of their strategy. It doesn't pay off immediately in terms of like number of plugins, but it expands their ecosystem, and it moves in the direction of, like, for Microsoft to not to be stuck with Windows, which is like the big effort for Microsoft the last years, is to escape the Windows trap. Because when they failed with Windows Phone, I guess there was some kind of panic, and they moved the direction to Azure. Now, if you look at the keynotes for Microsoft Build Conference, Windows is at the very low level, actually. The first is Azure, and the second is Office 365, and then you have Windows. So I guess it is this strategy. And how many companies? Very few. JetBrains is one of those. There are a lot of very small companies that do IO stuff. A lot, I mean, half a dozen.
Probably.
Excuse me?
Telerik probably too, with Just Code.
Telerik,
Oscode.
yeah, exactly. Oscode, they extend the debugger, I guess, in a different way. Probably more on the UI side than on the interacting with the stepper. So very few.
I mean, there's Foley as well.
There is Fodil,
Yeah,
but I cannot
that's very complex.
I cannot pronounce the name of our main competitor.
Do you have a special relationship with Microsoft? You have priority access to the knowledge somehow?
No longer, no. It proved to be useless. I had at some point. So there is no official relationship, but I find that the best comes from individual engineers. So not the organizational relationship, but engineers can be very helpful. But as an organization, Microsoft is not helpful to partner with. They don't care.
They don't appreciate you enhancing the
No.
studio with your product.
No, I would say they just ignore. We are under their radar, and but this is it. No. At some point, I had some like expectations or hopes, and we tried to be the first to adopt Roslyn in Visual Studio in 2015, and did a lot of work, and like hoped to have something in return, and like nothing happened. So we learned to ignore that and not to dramatize. It's that we are filling a hole. They are not interested in this hole. They are not interested in us to exist. It's still a fun job.
But it's weird.
Well, what is now Microsoft priority? Like, it is to expand platforms. Microsoft do not care about the productivity of users on their platform. It is not a priority. The productivity of .NET developers, in my opinion, has gone down significantly during the last years because of stability issues. So if Microsoft wanted to please existing customers, they would have slow release cycle with high quality, but they were losing to open source, to Linux, to JavaScript, Node.js. So they had to increase pace, which means to disappoint current customers, which is if you know this, must read from like startup literature the innovator dilemma. The innovator dilemma is basically you need to choose between pleasing your current customers and chasing new markets. So they took the decision to chase new markets, which is actually good for us because we could see that the whole .NET ecosystem was going down 3 years ago, and we are basically slaves to this ecosystem. We are a parasite of this ecosystem. So we need this ecosystem to actually survive. And now, because of their effort to move to new platforms, we have more customers. So eventually it is good, but it is really a lot of effort to follow that. The hard part is not to dramatize, take this as business and don't look at the hundreds of hours spent on Windows Phone.
Okay, but I mean, you're kind of perfect sparring partner for Microsoft because I guess you realizing bugs, whatever, or inefficiencies of the .NET ecosystem by using the super low level APIs, right? So I guess that the feedback that you're providing is high quality and super useful for Microsoft, no? How many bugs have you reported to Microsoft? What do you say?
Well, we try to minimize that because our experience is that there's not much feedback. Sometimes we get after a few months. We are very little for Microsoft. Well, I would agree with you, but it's not important that I agree. It would be more important that Microsoft agrees. Like when we use Azure, so we spend, I don't know, 600 euros per month in Azure. So we have an account manager, and they call us from time to time how we are going and say, but on Visual Studio there is no account manager. Nobody cares. Nobody cares. But that is, I told them, I was in Seattle, I told them, give us an account manager, talk to us twice a year, 1 hour, but anyway, these are corporates, they have processes, they are not going to have exceptions. But yeah, we are the most featured extension on Visual Studio, the most reviewed.
Yeah.
That's a bit like Kafka, Microsoft is huge as an organization, but I want to, really with individual engineers, you can have great contacts and great collaboration. But as with the institution, I think it is not worth the time of going to Seattle and having lunches.
How many licenses of PostSharp are in use? Do you disclose such figures?
Excuse me?
How many licenses of PostSharp are in use of the annual ones? Do you disclose these figures or is it a secret?
Currently, okay, 4 digits. Like commercial licenses.
Yeah.
That's commercial licenses. Yeah. Yeah, we also have these graphs. Yeah, more questions? Okay. Well, if there is no question, thank you for all this time you spent here. Did you write down this or you took a picture? You can take a license. And you have a last slide?
Yes, I have also ending slides.
Okay, I close it.
Yeah, it's on another slide. So, first, thanks to our speaker. And as every speaker now, you get a custom poster with our logo.
Thank you.
That's, I think, the 4th or so.
What is this wheel?
That's the Riesenrad.
Mm-hmm.
Ferris wheel in the plateau. So, also thanks to you all for coming and staying that long. Yeah, again, thanks to our sponsors. We had pizza and beer. Beer should be still there in the fridge. Yeah, you know, the training, the Global Day of Code Retreat, you should look at this and put these spaces. And yeah, once again, we are looking for new and additional locations to host the meetup. Please come to talk with me or with Martin. Yeah, 4th of November with the 2 talks. Announcement on meetup is out there since 11 o'clock or so. And yeah, the topics, nobody was in the break by me and talked a little bit of, or for some other topics.
Yes.
Offer something. Good, yeah, again, spread the word. We have 1 subscriber on YouTube during the talk. That's how you do it. Missing at least 15.
Subscribe to YouTube subscriptions.
Yeah, streaming the recordings will be probably in the next days out. I have to cut out the break to make it shorter, so it will take a little bit longer. So, and now, because you're all still here, we got
A raffle.
one day, no, not a raffle. We ordered swag for the .NET Conf stream last week, but it arrived on Tuesday. So I have a lot of stickers, and we also have this metallic straws for the .NET Conf 2019. So everybody can come to me and get one. Also the ones that don't were here. Good. That was. Thank you for all.
No updates.